Hello student, welcome to my video class. In this video we are going to we are going to learn about inverse of a function, as we have already completed a composite function. We have completed entire exercise, we have completed the theory of composite function, and there we have studied various method of drawing mapping diagram also, of composite of mapping diagram also. That knowledge will be helpful here. Let's proceed forward. You can see two mapping diagrams right here on your screen. Uh, Two mapping diagrams of two functions, function f and g. Function f is defined from set a to b, and function g is defined from b to a. Function f is defined from set a to b, and we can see is function f maps element p. Here it is important to know element p is mapped by function f to k, isn't it? P is on set a and k is on set b. And our another function g is defined from set b to a, and where g maps element k of set b to elements p of set a. In the function g, k is mapped to p, and in function f, p is mapped to k. In function g, k is mapped to p. And what's our conclusion is function g contradicts the action of function f. Whatever function f does, function g does exactly opposite of it, isn't it? Function g maps p to k, and function g maps k to p. And so we can say that function g contradicts the action of function f. It opposes the action of function f, and its action are opposite to the function f. Now, function f contradicts the action of g also. In a wider sense, in a broader sense, we can not only g contradicts f, also f contradicts g. Now we are very close to know what inverse of a function is. You might have built up some idea till now. Let's move to next slide. Here there is a mapping diagram of composite function FOG, and from this composite function we clearly know that f is the function which takes the input first. Let's see the mapping diagram, composite mapping diagram. This is the composite mapping diagram we have already done many times on previous videos. You can see f is the function which takes the input first, so f is here, the path is here, and g is the another function which takes the output of function f and carries and gives the output, its own output. And in a composite function, what happens in composite function is output of first function is taken by as an input by second function, isn't it? This is the output of f which is taken by this is the output of f which is taken as input by g, and it brings to here it brings to its output, and it is also the output of composite function GOF, isn't it? So input of composite function is p, and output of composite function is also p. Output and input are same, isn't it? Now let's see the key points from this mapping diagram. Input of GOF, composite function GOF, is p, and output of composite function GOF is also p. Here input equal to output. If input is equal to output, then student, you have to know while doing our revision, we have already written one definition, and that definition is of identity functions. So GOF is an identity function as input and output are the same or equal. So let's move to next slide. By definition of identity function, we can see GOFX is equal to x for all f, and as we said, g contradicts the action of f, f also contradicts the action of g, so we can write f of gx is equal to x. We have defined identity function in our previous classes as like this, as a single function, isn't it? In case of composite function also same. If the input is equal to output, here x is input, here x is output. You can see in composite function also x is input and x is output, x is input and x is output. So let's apply f inverse on both sides of this. FOG is equal to x. What we get, we have applied f inverse. You can see here f inverse is applied on both sides, which is in red. You can see throughout in red color f inverse. Now we can regroup it. It's applying, okay, don't get confused, it's not taking composite on both sides. दुईतिर composite लिएको हैन कि, we just applied f inverse on both sides. Now we can regroup as a bracket here, and we left G as it is, and f inverse. I think you have to be careful on this step. You have to see closely, focus here, and we just regrouped, isn't it? What we did is, if A and there is a bracket B and C, then what we can do is we can write AB bracket, and we can write C, isn't it? Exactly the same we did here also. Now what will be the value of A inverse and A? It will be 1, isn't it? It's identity. So f inverse f is also identity. We can see next step, gx is equal to f inverse, because this part is identity, this part is 1. We can write 1 here in this part. So gx is equal to f inverse. Similarly fx is equal to g inverse. We can find, if we apply g inverse in the first this expression, if we apply g inverse on this expression, we get the result, we get this result. So what we get is f inverse is equal to g, isn't it? Now I think you understood it. And if two functions are in, if two functions contradicts the action of each other, then their composite function will be the identity function. So one function can be called, or we can be said, the inverse of other function, isn't it? So let's define, very close to definition. Let's define. Now the definition is on your screen. F is a function from set A to B. We saw in mapping diagram also. G is a function from B to A. We also saw this also in mapping diagram. The function G is said to be the inverse of function F if this condition is true. We have already seen this condition in previous set. If this condition is true, which is identity function for all x belongs to real number. Here x belongs to real number because input is from real number and output is also from real number. Then we can say, then we can denote f inverse is equal to g, or g inverse is equal to f. In any way you can write. Okay, it's not like it's only f inverse is equal to g, in any way. Now let's move forward. It's the definition of inverse function. There is one cute note about inverse function, a small note, cute note. F inverse, if f inverse is the inverse of the function f, then the inverse of inverse is the function f itself. Okay, if we find the inverse of the inverse function, then our result will be the original function f. You have to keep this in mind. There may be a problem in the incoming classes where we have to find the inverse of inverse function. Already inverse will be given. So let's forward. Now we are going to verify different types of function, existence of inverse of a function on different types of function. There are 5 types of function. And does inverse exist on all type of function, or there are only few function on which inverse exists? We have to verify. We will check it, and we will derive one important conclusion which will be very helpful for you. Now the first function we are going to check is onto function. Does the inverse of onto function exist? Let's see a mapping diagram. This is a perfect onto function mapping diagram. It is onto function, and because none of the element in the set Q is unmapped, isn't it? None of the element in set Q is unmapped, so it is onto function. Let's see the inverse mapping of this function. I'm not saying inverse mapping is a function. We are going to check whether is the inverse mapping function or not. So we are just going to say inverse mapping only. Okay, inverse mapping is a function or not. Let's see the inverse mapping. H inverse, isn't it? It's just an inverse mapping where domain is 2, 5, and the range are, these are the range, isn't it? Now remember one thing. There is a reminder. To be a function, every element on the first set must have one and only one image on second set. Now what happens in the inverse mapping? There is element 5 which has 2 images, y and z. So let's see our conclusion. Element 5 of the first set had 2 images, and it contradicts the definition of function. This is the definition of function where every element on the first set which is p here of h, and for h inverse is function or not, where हामीले भनेका छैनौं कि यो h inverse function हो भनेर, हामी चेक गरिरहेका छौं. We are just examining it. Examination process is going on. Okay, so let's see. Element 5 of the first set has two images, and hence inverse mapping is not a function because it contradicts the definition of function. To be a function, every element on first set must have one and only one image. In this case, there are two images. Element 5 has two images, a y and z. So our conclusion is inverse does not exist when function is onto function. If the function is onto function, then we cannot find the inverse of that function. So one type, first type function is not, inverse function cannot exist. Okay, now the next is into function. This is a diagram for into function because one element in the set Q is unmapped, or we can say our range is the proper subset of codomain. Range 2 and 5 are range, and 2, 5, 7 are codomain, and range is the proper subset of codomain. So this is an into function. Now let's see the inverse mapping of H. Is it? We are going to check whether this inverse mapping is function or not. Now let's see. Let's remember again. There is a reminder for you that to be a function, every element on first set must have one and only one image. Every element. See this word every. Harek element. पहिलो set को हरेक element. See the first set is Q, and one element on the Q is unmapped. So our conclusion is element 5 of first set has two images. That also contradicts the definition of function. Also another thing contradicts is 7 of first set is unmapped. So every element must have one element, one image on set, second set, but our element second does not have image. So this contradicts the definition of function. We can say inverse mapping is not a function. That H inverse is not a function, and inverse does not exist when function is into function. We concluded two types, and in both types inverse does not exist. Now we still have three types. Let's see on one-to-one onto function. One-to-one onto function. Let's see the mapping diagram. It will be clear. It's one-to-one and onto also because none of the element on set B is unmapped. यहाँ set B मा कुनै पनि element खाली छैन. त्यो कारणले गर्दा onto पनि भयो र एउटा image को एउटा pre image छ. 1 को A छ, 2 को B छ, 4 को C छ. So one image has one pre image, so it is one to one, and none of the element on set B is unmapped, so it is onto one. So let's see the inverse mapping of F. We are checking it. We are examining it. We can see. Let's see the remainder. Does it goes with the remainder or not? Every element on the first set must have one and only one image. See, every element in the first set has one and only one image. Now it goes with the definition of function. So conclusions are every element on first set, that is B, has one and only one image on set. Isn't it? The first set is B for inverse mapping, and it has one and only one image on set B. That means inverse mapping is a function. Our F inverse is a function. So our F inverse is a function. So inverse exists when function is one to one onto. Still two functions are remaining. Two types are remaining, and out of three, one type has one type inverse exists, and the rest of the two types inverse does not exist. Let's move forward. Everything you have to write, whichever you are seeing on your screen, whatever you are seeing on your screen, you have to copy. You have to copy on your notebook whatever you have seen. Note copy. Let's move forward to one-to-one into function, and this is a mapping diagram for one-to-one into function. One function is unmapped, or you can say range is a proper subset of codomain. And inverse mapping of the function F, you can see inverse mapping also. And let's see that reminder. Now what does it says is every element, see every element, every element, see in the very first word also it contradicts. We can easily see 4 which is unmapped. Every element must have image, but 4 does not have image. So we quickly move to conclusion. Our conclusions are element 4 on first set, that is B, does not have image. So the inverse mapping is not a function. So function does not exist. Inverse does not exist when function is one to one into. Inverse exists when 1 to 1 onto, inverse does not exist when 1 to 1 into. onto हुँदाखेरि exist गरेको थियो, 1 to 1 onto हुँदाखेरि exist गरेको थियो, 1 to 1 into हुँदा exist गरेन. Now let's move to another function. Out of 4, only one function on only one type inverse exists. In rest of the 3 types, inverse does not exist. And now last type, many to one function. And let's see the inverse mapping. This is in many to one function because there is one element. There is instead B there is image 1 which has 2 pre-images. In this case we can say it is a many to one function. At least एउटा हुनुपर्छ, एउटा इमेज त्यस्तो हुनुपर्छ जसको more than one pre-image हुनुपर्छ. So one has 2 pre-image and 2 also has 2 pre-image, we can see. So it is a perfect many to one function, a mapping diagram for many to one function. Let's see the inverse mapping of G function. The inverse mapping, see inverse mapping, and let's see the reminder. What does reminder say? Every element on the first set must have one and only one image. Now this contradicts, isn't it, our mapping diagram? One has 2 images, isn't it? Our inverse mapping, G inverse, and inverse mapping G inverse, the first element 1 has 2 images and second element 2 also has 2 images. Now this contradicts our definition or criteria needed to be a function. So let's quickly move to conclusion. Our conclusion is element 1 on first set, that is B, have 2 images on set A, and also element 2 on first set have 2 images on set A, and also inverse mapping is not a function. Out of 5 types we did, only one type, 1 to 1 on to function on only on one type inverse exists. So our grand conclusion, overall conclusion is the condition or criteria for a function, condition, or we can say it as a criteria for a function to have inverse is the function must be, you can see, 1 to 1 onto, isn't it? If the function is 1 to 1 onto, then only inverse of a function is possible, it exists. Otherwise on the rest of the cases inverse does not exist. So thank you for being with me. See you on next video. Happy learning. Hope you understand this inverse of a function topic. Make a proper note and happy learning.